Hi, welcome to Elonix. In this video, we'll make an infrared proximity sensor circuit on a breadboard while simultaneously learning how it works. Also, the detecting range can be configured by adjusting the potentiometer. Our objective is to turn on LED or any other electronic device whenever any obstacle comes nearer than a specific distance. So let's start by placing the sensor element, which is infrared photodiode, on the breadboard. Energy from infrared radiation is absorbed by PN junction of the infrared photodiode and is converted to electrical energy, which is very less in magnitude. We can consider this as a tiny cell whose output current is directly proportional to the amount of infrared radiation falling on it. So, how can we use this current to trigger an LED? The best way is to translate current flowing from the sensor to voltage and then control LED basing on the magnitude of this voltage. Connect negative terminal of the infrared photodiode to positive rail, like we connect batteries in series, negative to positive, and its positive terminal to the negative rail via a 10K resistor. Every object in the surroundings emit infrared radiation and is not consistent. We need an external infrared source. So let's call upon infrared LED to provide us some infrared light which reflects and hits the photodiode whenever any object is in front of them. We need to connect positive terminal of the infrared LED to the positive rail and its negative terminal to the negative rail via a 270 ohm resistor. Now we have a setup where the voltage at this point is inversely proportional to the distance of obstacle from the sensor. So, as the obstacle comes nearer to the sensor, the amount of infrared light that reflects and falls on the infrared photodiode increases, which causes more current to flow through the resistor, and more the current, more is the voltage at this point, as we can deduce it from the Ohm's law, V is equal to IR, where R is constant and I, which is current, increases when an object approaches the proximity sensor. So, in short, the voltage at this point increases when any obstacle comes nearer. Now let's say we need to turn on LED whenever the obstacle comes below this level, and let's assume the voltage at this point is 2.2 volts. The condition we have now is whenever the voltage at this point is more than 2.2 volts, which can be named as reference voltage, we need to turn on the output. So for this comparison, let's call upon breadboard the most popular comparator, the LM358 IC. This operational amplifier has two comparators and each comparator has two inputs. One is named inverting input and the other non-inverting. In simple terms, if the voltage at non-inverting input is more than the voltage at the inverting input, the output turns on. All we need to do is use the comparator to turn on the output whenever the voltage at the infrared photodiode is more than the reference voltage. How do we provide a reference voltage that is adjustable? The best way is to use a potentiometer. So place it on the breadboard and connect one of its extreme terminals to the positive rail and the other extreme terminal to the negative rail. Now the voltage at the center terminal can be adjusted by turning the knob. So let's connect this to the inverting input, which is pin 2 of LM358, and connect the non-inverting input of LM358, which is pin 3, to the positive terminal of the infrared photodiode. So we have a setup where whenever any obstacle gets so close that the voltage at infrared photodiode is more than the reference voltage, which also means that the inverting input is more than the non-inverting input, the output turns on. So finally place an LED with its positive terminal connected to the output of LM358, which is pin 1, and its negative terminal connected to ground via a 270 ohm resistor. Connect the positive and negative terminals of the battery to the respective rails. Thanks for watching, do subscribe and have a nice day.